this video, we are going to be talking about end behavior specific for polynomial functions and what that looks like. Now, this is not going to be an explanation video as to why it is the way it is, but it's just going to give you a quick rundown of how you can determine what the end behavior does for any given polynomial function. So end behavior specifically is talking about what are my arrows doing at the end. So as my x's get bigger, what do my y's do? As my x's get smaller, what do my y's do? Okay, if we look at the parent function of x squared, we can remember that the parent function is going to be a parabola, which looks something like this. Now, as I continue to make it x to the fourth or x to the sixth, I'm going to get a similar parabola shape. It's going to change shapes just a little bit, slightly different U shape, but it's still going to act in a similar end behavior, meaning both of my arrows are going to go in the same direction. If you think about it, anytime I square a number, I'm going to get a larger number. If I take that same negative number, negative times a negative would give me a positive, so I'm going to continue to get larger y values. So that's why it happens that way. Now, if we remember, if we take a negative, we would just put it in front of any of those values. What I'm going to get is now my parabola or U shape is going to be pointing in the downward direction. And that's because now what I do first is I square that number and then multiply by this invisible -1. So this squared here only applies to the x, not the negative number. So now as my x's get larger, right? If I take that, let's take a 4 times 4 is 16 times the -1. Now I'm going to get a -16 number. So as my x's get larger, my y's get smaller. And in the same way, I still get -4 times -4, which is positive 16. But then I have that negative, which causes it to be negative again. So now as my x's get smaller, I get smaller and smaller y values. Okay. Now then, if I get over here and look at the cubic function, right, I have x cubed, or x to the third. What we're going to end up is getting kind of, I call it a broken parabola, right? So if I look at it, if I were to reflect this bottom piece right here back up to the top, you'll notice that we get a what would have been the parabola or parabola shape type look to it. But because it's negative now, anytime I take a number and cube it, right? Again, if I just take a regular positive number, the larger positive number, x value that I plug in there, I get larger y values. However, if I take that same negative value and plug it in, I've got negative times negative times negative, which would result in a negative. So now as my x's get smaller, now my y's are going to get smaller. And it's going to be the same thing for x to the fifth, x to the seventh. That odd exponent, okay, gives me, anytime I plug in a negative number, doesn't give me even pairs of negative numbers that would result in negative times a negative getting a positive, right? And then in a similar way, I can reflect that across the x-axis just like I did with the even valued ones, but now my shape looks like this. So again, I get similar things going on here. My end behavior now is going to be opposite, right? But if I reflect it across the x-axis, now I get end behavior that's opposite of what it would be if the negative wasn't out front. So how do I know which direction these things are pointing? Well, I'm going to look at the coefficient out in front. If it's positive, we're going to get a blue look right here, okay, on either one of these, meaning they're both pointing up in the case of an even degree polynomial, or in the case of an odd degree polynomial, we have opposite end behavior. And if we think about it like a book, if I read it left to right, I'm going to get a increasing function. Now, it faces down in the even degreed polynomial functions. I have a negative, so my end behaviors are still the same, but now I know they face down. And in a similar way, I'm going to reflect this blue line across the x-axis when I have a negative coefficient for my odd degree polynomials. Now, overall, if I think about it, as I go down, or excuse me, if I move across this graph left to right, it's going in a negative direction, so that would indicate a negative coefficient. Now, let me give you a real quick example here. We have the first one, we have a whole bunch of stuff going on, right? Before, we just had one term in my polynomial. Now I have 3 terms. So if you'll remember back what it means to be a leading coefficient, and that is the term with the largest exponent, which in this case would be -4x to the fourth. The degree is 4, so I know I'm going to have in behavior that acts similar to the even degreed polynomial functions. And then I have a -4, which tells me, okay, that's going to act more like the red one. And so what I know is now my end behavior is going to look something like this. Now, because there's a lot more going on with this polynomial function, it could kind of curve around and do all kinds of things in the middle. But what I do know is, and what's important here in this video is what's happening with my arrows. All right. Here's what I want you to do now. Just take a minute, pause the video, and then I want you to try this one for yourself. See if you can figure out or get the end behavior of what goes on. Again, the middle is not important right now. We're just trying to figure out what are my arrows doing. So pause that video, try it real quick, and then we'll check it. All right, so now that you've had a second to work on it, again, we're looking for the leading coefficient, which in this case would be plus x plus 5x to the fifth, which I know that's my leading coefficient because that's my highest degree. It's not what number's in front, it's what number has my highest exponent. So I'm going to have a degree of 5, which means it's going to act like the odd degree polynomials up here. And then now this positive 5 tells me it's going to act more like this blue one, meaning I'm going to have start with left to right. It's going to go in the upward direction. So what I know now is my end behavior is going to look something like this. And again, because we have all kinds of other terms in there, we could have some other things going on. We could have something like this. Again, we're not to that point. We just know that the end behavior acts like this. I have opposite directions and it's going up left to right. Hope this video helps, and we'll see you in the next one.